Hello everyone, welcome back. And in this section we are going to apply in code whatever we have learned in the last section, that is how to convert any text to vector and calculate term frequency and inverse document frequency of the documents, as well as understand the main applications of TF-IDF. Let's get started. So first of all, run this cell to connect to your Google Drive, and what we are doing here is nothing much. Basically we are loading the same movie plots path that we have, and I'm just loading the movie plots path as a data frame. So essentially we have our movie name, Wikipedia link and plot, as you can see. So this is the data that we collected using Beautiful Soup, nothing new. We have about 3,409 movie plots, and let's start with our analysis. First of all, we have this movie name column here. So why don't we just search for Batman Begins? So Batman Begins is a famous movie by Christopher Nolan, the director. Let's run this cell. So what we are doing here essentially is, from this data frame we are just getting the column that matches with Batman Begins, the movie name column that matches with Batman Begins, and if you have multiple of them, again you get a sub data frame. But essentially, since there is only one movie that starts with Batman Begins, we are going to get that as Batman Begins data frame. And in this data frame there is only one row, and what we are doing here is just extracting the Batman Begins plot from this. So we are just, since there is only one row, 0th row, we are just getting from this data frame the 0th one element and the column plot. That's what we are getting here. Let's print. So this is basically the text of Batman Begins movie, the movie plot. And along the way I'm going to introduce to again small tips and tricks that you can use. So oftentimes looking at data is very crucial, and if you need to scroll through a lot of data, usually you miss things, you miss looking at any formatting errors, etc. that occur. So one of the useful library is text wrap. Let's run this and see. What text wrap does is nothing complex. Since you have this whole text here that you need to scroll through, instead of that we are just dividing it into some fixed width. You can just play around with the width depending on the screen size that you have, but at the end of the day you can just print Batman Begins movie plot, and you can see that the width is cut off here, and you can just go through all the text that's there and see that everything is clean. Now let's go ahead with our exploration. Let's almost approach it just like a Python developer. You know nothing about natural language processing, and what is the first thing that you're going to do to this text is perhaps apply a split function, since it's string, and you're just going to split that splits on white spaces, and you're going to just divide that into word list. As you can see, what we did here is we took the Batman Begin plot and we just used the split function, that is the Python function to split string based on a space, and all you're doing is just collecting the words. Great. So now you just collected these words and you use the split function. Let's just take a look at things and see if everything is okay. In Gotham City, etc. Bats. So what we see here is that there's a comma that is already included in bats. So if you are going to find unique words and kind of create them as columns, etc., and find counters and other thing, how many times a word occurs, etc., bats comma is not, this comma shouldn't be included in this. The reason is that you want to avoid punctuation and you want to keep only column one column for this word bats, things like that. So what can you do better apart from just using string dot split function that splits on white spaces? Then comes the idea of regular expressions. Regular expressions are nothing but they are just pattern matching things that you can give to your text, and depending on the given pattern, it will divide the text into independent units based on the pattern that you gave. And you can just use import re regular expression. And what we are doing here is, let's see an example here where again we have comma included everywhere. Hello, I am Ramsri's string method. And what happens if we use just split is, since we are splitting on white space, comma is also included in the word that we get. But here what we are going to do is we are giving a regular expression, and this is the pattern. The pattern says match any single character letter that is alphanumeric. Alphanumeric means it can have what you see here is basically alphanumeric. It can have small a to z or capital A to z, and it can have 0 to 9 numbers included with underscore. What this says is that just match all the alphanumeric characters continuously that occur, including apostrophe. Let's just run this and see. As you can see, it is going to only match alphanumeric characters. So as soon as it finds comma, it's going to just exclude that. You got only continuous string of alphanumeric characters including apostrophe, as you can see here. But string comma, here it is broken at just string and comma is ignored. Similarly, you have method and exclamation, so method is ignored. So we got only these words. Now since we are trying to find the count of these numbers and other things, it's always good to extract the raw words than combined with punctuation. As you can see, we have removed the punctuation. So we are doing better than just splitting on space with regular expressions. Now for example, if you want to just retain these punctuation as well, what you can do is you can give this, which is match any alphanumeric character along with apostrophe, or match any of the punctuation that you see here. Let's run this and it will be clear. So here previously comma here and exclamation mark are ignored, but we are keeping those even because we are using a new regular expression that matches either a continuous string of alphanumeric characters or punctuation mentioned in this list. So as soon as we entered this punctuation, that's why these are extracted as separate list elements that you can see. Now depending on your text, depending on your data, you need to see what's the perfect way to split the text, whether you want to keep commas or you want to exclude them and things like that. But for most of our use case, we want to identify and count individual words that occur. So we don't really want punctuation and other things included with our words. We want to rather extract raw words. So we are going to use the first one itself, which is just split on continuous length of alphanumeric characters and ignore others. So let's run this, and this is the same that we have done previously, but we have now run it on Batman Begins plot. So you can see we got all the things. And the interesting thing is that bats comma, as you can see previously it was there, but now the comma is ignored. So you got individual words because now you can keep bats and automatically use that column to count the term frequency of bats or inverse document frequency of bats and other things, as you can see. So this text looks clean. Now if you have custom use cases, you can write better regular expression to split it in the format that you want. For example, sometimes you don't even want Ramsri's, you want to rather even ignore anything that comes after apostrophe immediately. Probably you just want to keep Ramsri and find its count as well. If you have such use cases, then you need to modify your regular expression accordingly. Now at the end of the day, what you're doing is splitting the text into some subtokens. As you can see here, subtokens are kind of words without any punctuation marks included. That's what we have defined as our tokens. Now someone can ask, is this the only way to tokenize it, and are tokens always proper words? The short answer is that no. When you go to advanced algorithms like transformers, etc., even the words that are there are subdivided. Why that happens is that sometimes there is a word like attacked, but rather you want to treat it as two separate words, attack plus ed, so as two separate tokens. And also there could be cases where there are words that you don't understand at all. There might be a new jargon, etc., that you used, but instead of completely taking that as new word, if you have, let's say, some word and it ends with ed, perhaps you can just divide that word into its subtokens again and ed as extra. So you can kind of understand it could be like verb, etc., etc. So at the end of the day, advanced algorithms like transformers, etc., even split words into its subwords. So when you talk about tokenization in advanced algorithms, it's even more granular. Even a word like attack could be subdivided into attack and ed, and similarly developing could be develop and ing, so it could be subdivided into two more tokens. At the end of the day, this is called as tokenization, and depending on your task, how you tokenize text differs quite a lot. So be very sure to understand that it's not always splitting by space or splitting by words and removing punctuation. Depends very specifically on your use case. For example, if you're training an algorithm for grammar correction, then you need to keep all these punctuation, etc., intact as well, and then you need to train classifiers or something like that to identify that the sentence is grammatically correct or things like that. So what I'm trying to say is that at the end of the day, it depends on your task, and you need to choose the right tokenization method that's perfect for your task. And here our task is more like finding similar movie plots and identifying keywords and other things. So we are dealing on a higher level task. So for us, dividing it into word level tokens like this is perfectly fine.